Okay. In this question, you're supposed to find the function that maps y onto z. Yeah? Okay, you can see here, x to z is g followed by f. So g followed by f is f gx. And your f gx is 6x minus 5. Can you see that? Starting from x, we go through function g, we follow by function f. Okay? So the result is 6x minus 5. Now at the same time, we have a function that maps x onto y. This function, how do you write this function? We write this as gx. Your gx is 2x plus 3. Now, to solve for function that maps y onto z, y onto x, I must go opposite. Meaning, I must find g inverse. Am I right? So we start by letting, do you want me to write the long way or short way? The long way is we let f g inverse x becomes y. Gy is now x. 2y plus 3 is x. Let's make y as a subject. X minus 3. X minus 3 over 2. Therefore, your g inverse x is x minus 3 over 2. Okay? Now, to find the function fx, there are actually two ways. Method 1, most people would prefer the substitution method. Okay? Substitution method works such that we let the function inside gx becomes y. So we can write this as fy. And fy is 6x minus 5. Okay? Now, why do I substitute gx with y? Because we want to reduce this from 2 function to 1 function. Now, I'm actually finding fx. Before you find fx, I must first find fy. To find fy, I must change all the x into y. So what is the relationship between x and y? Now we know gx is 2x plus 3. So we let this be y. And we make x as a subject. Now we take this and substitute inside. Okay. Can we cancel these two? As we multiply inside, we get 3y minus 9 minus 5. The answer is 3y minus 14. Now, if fy is 3y minus 14, fx equals 3x minus 14. However, actually for this question, method 2 is easier. Yeah, but I think a lot of people do not like method 2 because you're not familiar with it. It's called inverse method. You see, if I want to find f, I know f and g. I want to find f. I must get rid of g. How do you get rid of g? We put g inverse inside. Now I wonder whether you remember this, that if you have f inverse x, the result is the same as x. Yeah? When you start from x, you move backwards by inversing the function. Let's say you get y. Then followed by moving forward, you end up in the same position where you started. So if I put g inverse inside here, the g and g inverse will cancel each other, so you will get fx. But if I substitute g inverse inside my fgx, I must substitute my g inverse inside the x as well. See, if I replace x with g inverse, I must replace this x with g inverse. We already know the result from part A, right? That your g inverse is x minus 3 over 2. So as I cancel these two, I will get 3x minus 9 minus 5, which is 3x minus 14. Now you can see it's somewhat similar to the substitution method, but I don't have to rearrange the equation again because I've got this result already. I simply use the result from A1 and substitute inside here. As for part B, find the value of x such that gfx is mapped onto itself. A function is mapped onto itself when the object is equals the image. What is your g? What is your fx? My fx is this, 3x minus 14. Let us substitute inside. What is your gx? Your gx is 2x plus 3. Let's put 2 of 3x minus 14 plus 3 equals x. So just expand. Bring over, you can write this as what? 5x equals to 25. Yes, x is therefore equals to 5. Okay?